So okay, in this part we're going to look upon how well we're going to uh, do my processing of the data of linear regression. Since that's simple linear regression where we've got different uh, types of linear regression, and that's pretty the most simplest of them. So which holds a relation of y is equal to mx plus c, which where m is the slope and c is the intercept, which we just looking in the last part. Uh, and now we talk about the Python programming. It's like a bit easier, most easier programming, which holds so many libraries. Even its syntax is easiest to understand. Even it's self-explanatory in many of the terms, which is not quite observable in different programming languages. So this whole set is not so big. How we're going to look upon simple integration? So it's divided into different parts. So we're going to look up on this one, like how we're going to proceed. So when we begin to proceed, we have to import some libraries because Python holds some exciting libraries, and since we are dealing with the numbers over here, so we're going to import NumPy because my NumPy is a library of the Python programming language, which helps in adding support for large and multi-dimensional arrays and matrices and collection of high-level mathematical function which are used to operate on arrays. It's okay. So we're going to import NumPy with name as NP because that's the word I'm going to use where I'm going to use my NumPy library. And if I'm going to jump to pandas, then my pandas is a library which is used for data manipulations and analysis. In between of them, I just import matplotlib.pyplot as a PLT because it's going to help me to plot the graph. So it's a sub library. So I'm going to use matplotlib as with the name PLT. Okay. So now, first of all, we need to import the dataset. Before importing dataset, it's required that we import the dataset into uh, our system. Where here we have used Google Colab. For Python programming, we have got different compilers for that, and Google Colab is one of the most, you know, the usable and exciting one, and that's the most preferable, I would say. So I imported the dataset set data cs, which commonly looks like this. We have got two sections over there, A and B. A holds for the the experience in the years, and that's the salary. So we can see that the relation is quite easier, that as experience increases, my salary also increases with that. But what's the relation? That's what we are looking for. So in this part, we have put as x and y. So x is the one which is, you know dataset.ilog, that's the syntax, and y is dataset.i locations. It specifies the locations from which it's going to took the values. So if you look upon this, x comes in the first row and b comes in this, sorry, in the first column, b comes in the second column, and they're going to have all the columns. So when we have going to have all the columns, then we can specify like that in this terms. And since I'm going to omit the last column, or to say only first column, I can write in this way. And for y, you know only the last column, that's we can specify like by -1, and that values, it's not that important anyway, but the idea we have to get from this. Now what important over here is that when I'm training my set, I have to split into two. One is the training set, and another one is the test set. So from SK.learn model selection, import train test split, and this is the one of the library which helps you to split the data. So I'm going to use something as train test and y train y test, and this is the text and my test size. First of all, I'm going to train the model from the you know training sets. So I have split on random